Oh my gosh, class is over. We start and class is over. Evan, good to see you here. How's everyone doing today? We got MuteBot in the chat. The assignment that's due is locked until Friday. Oh my gosh. Can you not see it anymore? I think I must have done some. And it's also due Friday. Yep, that's the way it goes. You got about 1 minute to do it. Noel, good to see you there. For BAS 320, your assignment is due Friday and it releases on Friday. Let's just keep it that way. I think I might have made an error when I was doing some updates yesterday, Evan. Let's not do that to you. Let's not be mean. What do you say, Evan? We make some changes here? I'm logging into, it's gonna let me log in. 1 minute assignments are cool if they're easy. The assignment is be awake at 11:59. Can we go over quiz and data analytics? You got it, Noel. Let me fix this up for BAS 320 right here and unlock their assignment. So make sure these are set up properly right here. So KUB data. KUB. Can we go over the partial F test? Yeah, we'll start partial F, then we'll head into some 201. You got it. Let's talk about the partial F. Let me load up our studio so I can talk about partial F test. And available from. There it is. Okay, so I think that fixes, I think it has to be the until. So I think they changed the way Canvas works. And yeah, they changed the way this works. So, okay, I think that's, nope. Stop changing my things. 12 p.m. Okay, I think that fixes that one. KB data. I'm trying to fix this one too here. And we're getting this fixed. You were trying to open, I was trying to open the quiz? That's all right. MuteBot is alive today. Just say MuteBot. He's in the chat. Feel free to talk to him. He should be there. Double check on MuteBot for me. Double check on MuteBot for me. Is MuteBot there? You should say I am MuteBot to that. I am MuteBot. He's there. If you say MuteBot, he will respond. You are. So MuteBot is in the chat. And I think it should be fixed on the assignments now, Evan. Let's go ahead and take a look at a partial F test here. Crazy hair. Crazy hair. Let's do this. I think the lab should be unlocked now too. Tell me if they're opened or unlocked now. I think I made some changes that messed them up. So let me know if they are fixed now. Try reloading those pages. So thank you, Evan, for that right there. I really appreciate it. And let's put this in the notes. 4:33. Closed until 4? Let me look at the lab again. I thought it'd save on the changes. It's literally not saving my changes. Clear, save. Okay. We'll do the automatic character recognition device. You got it. Okay, I just hit save again, Evan. Tell me if that fixed it. I'm literally clicking save on these. Oh my gosh, it's not saving the changes. Available from. I'm going to put like yesteryear, way forever ago. Yeah, I know, right? They're both locked now. Okay, so now take a look at it. I'm triple checking. One of them should be open. Okay, both should be open now. Tell me if both are open now. So take a look both now. I swear I changed it. I changed it yesterday and something's happening where it's like not saving. They are open good. I was literally just a moment ago doing the saves, but I think like you have to hit like clear on it. So if you don't hit clear, it doesn't clear it even if you delete it. So I clicked clear on it and then that fixed it. And I also put one to a previous state to see if both methods would work. Okay, the partial F test. So what is a partial F test? So if you're watching this video, all these quizzes. So the F test itself, the F test itself is if we make a model to predict the weight of a car based on the miles per gallon from the data MT cars. This is a data set everyone has inside of R, so you can use it at any time. And down here at the bottom, you see the F test. Notice right here, we have the F statistic, and any test in statistics will have a what associated with it. Any test, and this is a good question, Noel, also, or anyone with 201, any test in statistics will have a what associated with it when you see the result of the test. P-value, great job, Evan, right there. You're so quick. Also, I don't know, I was like, wow, Evan, are you MuteBot? Are you MuBot?
I am.
Is that the I am MuBot button? P-value. Yep, the p-value. So the f-test right here comes back as statistically significant, and in the simple world, it is the p-value of the x, and we actually saw this with regression in 201, that the x variable is the p-value of the model. So if you're looking for the significance of the model, you can look to the x. But when you go to the multiple model, if we add in something like cylinders right here, and what is another one in MT cars? Another variable would be gear. So we're adding in multiple x's. Oh, Evan, what's going on, man? So now if you notice right here, we have multiple x's in the model. So we have miles per gallon, we have cylinder, we have gear, and now the significance of the model is the x versus previously the x itself was the significance of the model. Here's the significance of the model, which is the significance of the x. But now since we have multiple x's, the significance of the model is kind of its own thing. Does the model itself reduce the variation in the y variable in a significant way that is unlikely by random chance? Do the x's contribute? Now, you have cylinder right here, and cylinder by itself might be significant. To see if cylinder by itself is significant, which it is, we have to look at a model with just cylinder. So, Evan, quick question. What does it mean that cylinder in the multiple model is not significant? What does it mean that cylinder in the multiple model is not significant? Really good question, especially a test question. What does it mean that cylinder by itself in the multiple model is not significant? What does that mean? Very good theoretical question about significance in multiple models. What does it mean that cylinder by itself is not significant? What does that mean? Because we can see cylinder is significant in predicting miles per gallon, but in the multiple model, it's not significant. What does that tell us? I'll give it a moment. So, well, good or bad, good or bad. Good or bad is all subjective. Its p-values just are what they are. What the low p-value, or what a low p-value here means is these variables bring with them new information that significantly reduces the variation in the y, and they help the model in a way that the other variables aren't helping. So this variable now, cylinder, does not bring new information. And we could check to see if it brings redundant information by running what code? How could we check to see if it brings redundant information? How could we check to see if it brings redundant information? Simple code, VIF. VIF is variance inflation factor, which measures the overlapping variation. So they could not find the function VIF. Is that in reg class? Did Petrie write a VIF function? Maybe. There it is. Cylinder and miles per gallon look to have some redundant information, not that high. High VIFs are considered 5 or 10. I could go into the calculations of how VIFs are done with R squared sub I, which we talked about in class. But there's a little bit of redundancy, but seems like cylinder just doesn't bring with it a lot of new information. So the question becomes, should we be even doing this big model? So we have a big model and we have a small model. Does that make sense? My small model has what x's? I'll put them right here next to each other. My small model has what x's? And this is where we get into the partial f right here. And this is also, does the multiple regression process go as scatterplot matrix, linear model, check, kind of. I'll go through that. Good question, Emma. Let me pin that, and I'll talk through that here, because we'll do partial f right here. So this is where the partial f comes into play. What is the point of a partial f? So you have to think, why would I ever do a partial f test? Good note to have, why do you do a partial f test? Now, an f test is when you go, what an f test looks like is, you go from 0 variables to something like 3. Doing this right here is an f test, because you're going from nothing in your model to 3 variables. A partial f could be something like going from 1, so this would be partial f, so partial f. So you start with variables already in the model, and you look to see if adding more variables is significant from your starting point with variables in the model. So kind of, it can be used to remove variables or add variables. So you could ask, should I go from 1 to 3? Should I go from 3 to 1? And the point of the test is to see if the variables bring with them new information. So when we run a partial f, I always ask, I think it's small to big. I always ask and I get it wrong. So there it is right here. Ooh, what does this mean? Look at this. Remember how the difference between these is two variables? You can see it right here. So there's a two variable difference between these models. And you can see right there in the degrees of freedom. It's really about one of the few things we care about in this output other than the p-value. So what is the decision from this p-value? What is the decision from the p-value? What do you learn from this partial f-test? What have we learned from doing the partial f-test? I'm going to comment on your comment. Correct. And it just depends on how you phrase it. Evan, that's a great way of phrasing it. Let me throw you some MuBot points. So the way I'd phrase it is, the test did not come back significant. The new variables, the two new ones right here, do not bring with them, they do not explain a significant amount of variation that is unlikely by random chance. So the two variables do not bring with them new information that is unlikely by random chance explained, as in they don't do anything to help us. The amount of variation they explain could just be by random chance, hence high p-value. So we shouldn't put the variables in the model, or you could say we should remove them. So the outcome of a partial f-test will be the p-value, because that's what a test comes back with when we run in statistics. And the choice right here is to not have the variables in the model. Whether you say don't put them in or remove them, the choice would be do not put the variables in the model. So the point of a partial f-test is to test a small versus big model to see if adding in the variables explains variation. The full f-test is to look at all the variables in the model. The partial f-test is to look at a set of predictors to see if this set of predictors brings with it new information from the starting point with a variable already in the model, or multiple variables. But now I've been asked a really great question right here, and let's review this. Kind of the process. So when you do a multiple regression, you can do things like a scatter plot matrix to start. And there's a really good function. It's in the psych package. I might have set library psych on here. There we go. There's a matrix in here. Core matrix? No! Let me see here. Okay. Correlation's just enough. Where is it? Oh, this is a good site. I created one in the NFL assignment that I wanted. Yeah, definitely. They might be using the psych package here. Where's psych? Oh, wait, here, literally I find it right here. Core.test. I don't want to do core.test. Feels like my wife's boop boops. No, it's my sister. They should. Did they use psych? Really? They're going to use psych and then they're not going to use the really cool stuff? Let me say matrix. Here we go. That's really good. Core plot. That's decent. Core plot from psych package. And woo! Oh my gosh, that's a mess right now. We might limit our view on this. You could go to something like only the first 4 columns. That is way too big of text. There we go. Make my fonts way smaller. And you can see, I wish it didn't put, so it's got the +1. Not loving it as much, but I thought the graphic looked better. Let me try one last thing right here, Evan. ggplot correlation matrix plot. I thought there was something in ggcoreplot. What package is this in? ggcoreplot. ggcoreplot is in oh, it's its own package. And oh, do I have to go to DevTools? Oh, no, it's there. That's not nice. 2 more tries, Evan. Load. Oh, nice. Yeah. Oh, you're using Tidyverse, data process, ggally. Yeah, ggally. What does ggally have in it that you're using, Evan? What function are you using? Filter. You're filtering your data. What function are you using in ggally? Wait, stop pausing for a second. Wait. Thank you, Evan. Which function are you using in ggally? Here it is, correlation matrix with ggally. GG pairs. It's just GG pairs. GG pairs. I've used GG pairs. Here we go. Wait, I'm gonna, just in case, since this is the assignment, I'm gonna, just in case, I'm just gonna remove to get the whole code image. Yeah. Discord it to me, just in case Discord it to me. And I'll go, thank you, Evan. No, you were fine, nothing bad. And you can see the correlation values. Problem is, you get a lot of data, it can be really messy to look through a lot of data, and it's iffy about how much you should put in reports and how you should put them into reports a lot of times, because if you get so much data, it just gets to be a huge mess. And you can look through, like with miles per gallon, to see the strongest correlations. And what's interesting is cylinders actually has this very strong correlation, but then with the multicollinearity, it doesn't become significant. So to your question, we might start by investigating with the scatter plot matrix. That's pretty good, and correlation values. You could also use all correlations to create a list. So all correlations can be run on it with interest equals MPG, and then you could go here and say sorted equals strength, and so you can see the strongest correlations is weight, cylinder, displacement, and they're all statistically significant, but they probably all share some variation. And then check the summary statistics, QQ plots, histograms, p-values, and VIFs, pretty much. And you can look at the influence plots. You can see for influential points in the model, and we don't have any highly influential points here because it came back with 0. So influential plots can be done too. Predictions can be done with the model. It all depends on what you want to do. Does that make sense, Evan, to your question? Like, you have to think, why do you do each of these? You run check regression to make sure your model doesn't have issues. The whole point of a check regression is, does my model have issues? And the answer is no, but not a big one. I'm not going to, we could put extra equals true on this and view the extra plots. We need to look at gear, and it's the far right one. It bends a little bit at the end. Do you mind like speed running of the tests? Like, reason we do the tests? Yeah, which tests? And then I'll hop to some 201. Which tests are you thinking about? Like, each one of these commands has a different reason. Influence plots is done to see if there's any highly influential points in the model that might be pulling it in a direction. The size of the circle represents the size of the influence. To have influence, a point must have leverage, far away from the mean of the x's, and a residual. And delete is scrutinized residual to be specific, but it's based on residual, which means it's far away from the model. None of these points meet the metric to be highly influential, so none of the points, integer 0 means a vector of 0 length, that is integer in class, we got no values that are no rows are highly influential. Check regression is done to see if there's problems with our model. So are there problems with the linearity of any of the x's? A small problem with gear, but I'm not so concerned about it. I looked at the plot, and the p-value is not super duper low. No problems with the other ones because all the p-values are above 0.05. The null hypothesis is that we pass all the conditions. Any p-value that is below 0.05 needs to be checked, and you need to look at its respective plot, like gear's plot is looked at. And I don't see huge issues. I see a small bend at the end. If you notice, the point's kind of a mean more down there. I think it's picking up on that. It's being a little overly sensitive, as tests can do. All correlations is done to look at all the correlations. So when you have quantitative variables, you can find all the correlations. You can pick an interest of a variable you want to see over here. It'll switch between variable 1 and 2, but it'll always include it in it. It's just that MPG was first, and that's why it always appears on that side, the way Petri wrote the code. But gear now is always in the combination of variable 1, variable 2, and I sorted by strength, which puts it from absolute value strongest to weakest. It's just irony that all the negative ones are there. If you go to, oh no, it is magnitude. I like magnitude better. Magnitude. Magnitude goes by absolute value, which is the one I actually prefer, because now you can look at the absolute value of the correlation, which is the strongest. And so you can see the strongest correlations to the weakest correlations, which are closer to 0. When we have up here hey, Caroline, good to see you there. Yeah, let's do data analytics next. You got it. Data analytics coming up next. Summary is done to get a summary of your model and to see the significance of coefficients. The first thing we have is the equation of the model. Then we have the residuals telling us if there are extreme things. There's a high point. We actually maybe saw that in our plot back here. It looks to be this one, but it's not highly influential, but that's the biggest residual furthest away from the model. You can tell by it being way above. This is a deleted studentized residual, so these are basically z-scores. So that is a very unusual with a z-score of about 3, technically t-score, but who's counting? T's and z's are virtually identical. You have the estimates of the intercept along with its uncertainty, its t-value, which is the standardized value, and a p-value telling you the significance of all these. Same thing for all the x's in the model. The significant codes telling you whether or not something's significant. The more stars it has, the more significant. One dot has a p-value between here and here, hence this is below 0.05, but not below 0.01. You have the root mean squared error, which is the typical miss the model makes. Degrees of freedom we don't talk about because no one cares about them. R squared is the percent of variation y explained by the variation x. Root means, R squared adjusted is a more fair look at how the R squared is doing. The F statistic is a measurement of the observed variation over the expected amount of variation, which says that we have about 35 times observed variation being explained versus what we would expect by random chance. I'm not going to quiz you on that, but it's a neat fact. It's also in the simple world, square root of the t. Degrees of freedom are used to calculate the p-value from the F, numerator and denominator. Not going to talk about that. P-value right here is the important part though, because that is the overall significance of the model. Does that help a little bit, Evan? If you have other specific tests you want me to talk about or do, let me know. But the key is know the output. So maybe slow down the video, write down what I say, talk about the important things like what is the typical miss the model makes, root mean square error, what percent of the variation y is explained by the variation x, R squared, what's a more fair look at that, adjusted R squared, is our model significance, p-value of the F test for the model, are our x's bringing new information, p-value of each of the individual x's, how do you write out the model, the estimates of the x's. So all these things right there kind of build up to our knowledge, and then we just practice and know like, what is the typical miss the model makes, root mean square error, where's that found, residual standard error in the summary output. So you just, it's like, just practicing. Every time you see it, you just have to be like, how do I interpret that? How do I interpret that? What does that mean? What does that mean? You're welcome, Evan. Thank you so much, Evan, right there. We got 2 questions right here. We're going to do Noelle's first. Actually, I did say we're going to do Caroline. Caroline, we will do yours coming up here next. I told Noelle we would do hers. And which chapter is that from, Noelle? Can you remind me which chapter? Let me take the note on it right here. 24, I'm taking a guess. 2413, Stat 201. I think this is chapter 13, right? Chapter 13. So chapter 13, quiz MyPearson. In automatic character recognition. Okay. Automatic. Let's check this out. Thank you, everybody. Lots of good work. And thank you, Evan, for swinging by. We do a lot of 201, but we do other classes too here. Haven't had a 479 swing by lately. Okay. Little chill music right here as we get started. I was able to get it right on the homework, but I don't understand the process. Oh, let's take a look. Chapter 13, sampling distributions of the sample proportion. Let's do it. No, wrong button. Here we are. We're going to go find that question real quick. Then we're going to do some data analytics. Takes me longer than I thought to get over here. Where am I? Okay, there we go. Oops. An automatic character recognition machine. Here we are. An automatic character recognition machine successfully reads 85% of the handwritten card applications. So this is a simulation right here asking you what you would expect to see if we have a sample size of 20, 50, 75, and 100. Now, the important things to know for this is some key facts. Let's write down all the key facts that will help us solve this. First off, the 3 conditions for the distribution of the sample proportion to be normal. The 3 conditions. Mine is a different version. It's not this one right here, but it's a little different. Let me look because there's another version. Thank you, Noelle. Here we are. Very similar. It's probably this one right here. Let's take a look. So we have the same thing going on with the sample sizes right here and the true proportion. So let's look at the key facts we have to know to solve this. The 3 conditions for the sampling distribution of the sample proportion to be normal. The notation. And last but not least, key facts. Okay. So what are the three conditions for the sampling distribution of the sample proportion to be normal? Do you know the three conditions? The three conditions. Condition 1. What are the three conditions for the sampling distribution of the sample proportion to be normal? If we meet these three conditions, it'll be normally distributed. What are the three conditions? What are the three conditions? Well, if it is a normal curve, it'll be normal. So the conditions are randomly selected, less than 10% of the population selected, and at least 10 successes and 10 failures. So at least 10 successes and at least 10 failures. And we've already written some notation, so we got to know the notation next. So we have to know the notation. So greater than or equal to 10. Sure, I like that better. The notation right here is very important because it's going to use some key facts. We have mu p hat equals to p. What does p stand for here? What does p mean? So mu p hat is the mean, the mean of the distribution, the mean of the sample proportion. It's what you would expect to see if you took a sample. So it's saying something like, I'd expect this percent mean of sample, you can barely read that. Mean of sample proportion, mean of sample proportion. Well, whoops. What is P, Noel? What does P mean? Just what is P? This says mean of sample proportion. What is P? That's what mu P hat is. What is P? We have to know the notation to solve this. What's P? So, in statistical notation, what is P? Well, P hat is the guess. P hat is the guess. P is the true proportion. But think about this. If 40% of UT is out of state, if you took a sample of 100 students, what percent of them would you expect to be out of state? If 40% of UT is out of state, if you took a sample, what percent would you expect in your sample to see out of state? Notice how I highlighted that? What percent would you expect in your sample to be out of state? 40%. If you took a sample of 200, what percent of your sample would you expect to be out of state? So if 40% of UT students are out of state, and you took a sample of 200, what percent of your sample would you expect to be out of state? So how would you do that one? Well, I'm telling you 40% of UT is out of state. What percent would you then expect in a sample to be out of state? So 40%, and you take 200 students, what percent of the 200 would you expect to be out of state? Well, now you're going for the amount, though. You might be going for the amount. That's the amount. Percent is just going to be, I'd expect 40%. So if 40% of UT students are out of state, then I expect 40% of UT students out of 200 to be out of state. What about 2,000 students? If you took 2,000 students, what percent of the 2,000 would you expect to be out of state? What percent of the 2,000? So if we know that 40% of UT students from the registrar are out of state, what percent of the 2,000 would you expect to be out of state? It'd be 40%. It's that mu p hat equals p. So if you know what p is, then that is mu p hat. Now mu p hat's not an equation. It's not mu times p hat. It's a phrase, the mean of the sample proportion, just like when we do the standard deviation of the sample proportion, the variation in the sample proportion. So this is standard deviation of sample proportion. So sample proportion right there is equal to p times q over n square root. So how could we get, if p is 0.40, how can we get q, Noel? How can we get q? So q is equal to what? How would we get q? Q, how do we get q? There's q. Correct. And then make sure to do it as decimal. Good work, Noel. Mubot points. So Q is 1 minus P. That's all Q is. It's complement of P. So make sure to do it as decimal, though. Q is 1 minus P. It's 60%. And then you plug in, and you can take your sample size right there and get the standard deviation, which is the variation. Now, notice what happens as n gets larger here. If n gets larger, standard deviation will do what? Because you're dividing by a bigger number. So as n gets larger, the standard deviation of the distribution will do what? As n gets larger, the standard deviation of a distribution will do what? As n gets larger, because you're dividing by a bigger number, it gets smaller. So standard deviation will decrease. What happens if n gets larger over here? What happens to p, or mu p hat more specifically? What happens to mu p hat right there if n gets larger? It stays the same. So larger n leads to smaller standard deviation. Larger n does not impact, or n does not impact, sample size, which is n, does not impact the mean of the distribution. So one last key fact, though, is that we need at least 10 successes, at least 10 failures. And I'm going to show you this right here, and you can see it if I go to a binomial distribution applet. If we were to go to the binomial distribution applet, and if we have 85% success rate, but we only have a sample size, oh, that's the sample size. If we have an 85% success rate on this machine and we only have a sample size of 20, well, let's go down to 2. That distribution is highly what, Noel? Left skew, right skew. Think Monster Man. That distribution is highly what? Left skew, right skew, think Monster Man. This is an extremely great job, Noah, right there. Extremely left skew distribution. You can see Monster Man right there. Extremely left skew, right to the high, left to the low, whatever way the tail goes. But as you go towards 10 successes, 10 failures, take a look at what happens. So when we go towards it and we get more observations, the distribution starts to become more normal. To at some point, it's basically a normal distribution. Once again, as we get more successes, because now you're timesing it by how many, the p times n, because how would I know how many successes there are? Let me go back to the calculator. Really? I'm just going to click around. How do you know how many successes there are? Calculator here. You say 85% of 500 is the amount of successes, and thus the failures, notice this down there on the bottom, is 15% of 500, which is the amount of failures. Notice we have at least 10 successes, at least 10 failures, and if we randomly select the data, it's less than 10% of the population, and we have at least 10 successes, at least 10 failures. The data will be, say it with me, Noel, for some points, the data will be what? If we meet all the conditions, we have randomly selected the data, we have less than 10% of the total population, we will have at least 10 successes, at least 10 failures. The data will be what shape? The data will be what shape? What shape will the data be? If we meet the conditions, which is the point to check the conditions when doing sampling distributions, this is on the test too, it'll be normal. So we have to meet the conditions to use the normal. So notice right here, the data is left skewed to begin with, probably because we don't meet the conditions. If you look at a sample size of 50 right here, with the sample size of 50, that might be enough to meet the conditions, but let's check. Remember the P times Q, or P, NP, and Q condition, successes and failures? Well, if we have 50 trials and we have a success rate of 85, that's 42.5 successes. But now Q is 0.15, because remember, we're just taking the complement of P, 1 minus P is Q. With 50 trials, we'd expect not 10 successes. So it may not look this, but this is still left skewed. Let's check the next one to see if it's left skewed or right or normal. So with 75 observations, how many failures would we expect? Really good test question here. Success rate is 85%, failure rate is 15%. So with 75 sample size, how many failures would we expect, Noel? Failure rate is 15%. Sample amount is 75. How many failures would you expect? How many failures would you expect? Failure rate is 15%. Sample size is 75. How many failures? You technically only have to check the smaller of the two proportions. because that's where the issue will be, where there's not at least 10. Not divided. NP, NQ. Good guess right there. Let me throw you some points. NP, NQ. So let's check the conditions again. It's checked by seeing if NP and NQ, which we find the sample size times P, the sample size times Q, and we see if those are greater than or equal to 10. And so we take P right there, or Q, and we times it by the sample size, and there's the amount of successes. So do we pass the condition? Do you think we pass the condition, yes or no? The condition is we need at least 10 successes, at least 10 failures. Do we pass the condition? We do. There's at least 10 failures. And we could check successes too by taking 75 times 0.85. This will be the bigger number. So we have at least 10 successes, at least 10 failures, which means increasing the sample size is we're still going to pass it. So this one is left skewed. This one is left skewed. This is normal. This is normal. So when we take a look, we can say that this one is left skewed, normal, normal, because we checked the conditions and we figured out when it met it. It met it at 75, which was here. For the next one, we'll do the easy one first, and then we'll do the hard one last. Notice that the standard deviation, or excuse me, the range is getting water, Noel. The range of these graphics, as you increase the sample size, which is a key fact that we stated, is getting water. The range of these graphics, and I'll highlight what I'm talking about, is getting water. And so the range of these graphics, which is measured by min to max, is getting smaller. And remember, that was one of our key facts. We wrote down a key fact that as sample size increases, the range, or the standard deviation, which is not part of range, but associated with range, that the standard deviation will get smaller because we're dividing by square root of n for the spread of the data. So all you do right here is figure out the range, which is 0.5, 0.35, 0.35. I'm just subtracting these numbers right here, subtracting those numbers, and 0.20. So 0.5, 0.35, 0.35, 0.20. Then you figure out where it lands in these blanks you can check. Can you show me again where you found the values to put in the formula? Which formula? This right here, good question. Are you talking about this? You're taking max minus min for range, max minus min, 1 minus 0.65, 1 minus 0.65, and 0.95 minus 0.75. Yes. So for the NPNQ, we need to find all the N's and all the P's and all the Q's. So to check it, we have to write P equals 0.85, Q equals 0.15, found via P right here. And once we find P, we can find Q. And then we need to check it for each N. These are all the N's right there. So we'd go right here, we'd make a table if we want, and go N, and then NP, NQ, and we'd have N of 20, 50, 75, and 100. And NP is going to be, we're just timesing right here, 20 times 0.85, 50 times 0.85, and then 75 times 0.85, 100 times 0.85, and then 20 times 0.15, 50 times 0.15, 75 times 0.15, and you'll solve all these out to see if they're at least 10. And when you finish the table right here, you get values. Oh yeah, P and Q don't change because the truth is that the machine has a success rate of reading it of 75%, I believe. So P and Q are what the problem says, that it reads it correctly 75% of the time. It even states down here that the true proportion of correct reads is 85%. Good questions, Noel. And those numbers that we did just a moment ago were 0.5, which is greater than that, 0.35, which is in this range, 0.35, which is in this range, and last but not least, 0.25, it was 0.20, which is in this range right here. The last one I don't love, and if you do make a mistake, especially if you're in my class, if you make a mistake on this one, let me know, this portion right here, because here's the thing, the mean doesn't change, but they get a little tricky on how you have to answer this, because I have missed it, and I'll tell you why. With this, if 0.85 is in the range, it's a viable answer, and they have done it really weird sometimes. I get really mad when they, hopefully we don't get a really weird one. Here's the way to do it quickly, but you might make a mistake. 0.85 is in the range because the truth, and that's where the center of the distribution is at. The center is where the truth is at because that's where mu p hat is. Remember we talked about mu p hat? They're literally asking you, where is mu p hat? And that's what this question is asking with the center because mu p hat is the center. So we look for 0.85 again, and here's where we run into a problem. Both of these have 0.85. Because of that, you need to go to the histograms and look at the one that is respective to it for sample size. 0.65, 0.75, oh no, excuse me, 0.65, 0.7, 0.75, 0.8, 0.85, and this is the highest peak. Since this is the highest peak, they're calling this the center from 0.8 to 0.85, and you have to count up going by the bars in the histogram. So the answer for this one is 0.8 to 0.85. The answer should just be it's always around 0.85. That's the truth. And so the next one, 0.85. Once again, we got the problem that 0.85 is top and bottom to one of these. How can you tell it's 0.8 to 0.9? So going right here, we look for where the peak in the data is. And you go here, 0.5, 0.6, 0.7, 0.8, 0.9. And the peak right here is from 0.8 to 0.9. So the peak right there. Good questions. Going down here, the next one. Oh, this one right here, I didn't look at it yet. This one, we got to do the same thing. This is in quarter units. So this is 0.7, 0.25, 0.725, 0.75. And we got to go to this peak right here, which is going to be, you can go up in 5 units, 70, 75, 80, 85. So 85 is the start of it because each of these is a 5-unit difference, 85 to 87.5. Ugh, I got the really hard version, 85 to 87.5. Next one, 85 is at the center right there. Notice how 85 is in the middle of that. So we should be good. I have seen where it doesn't count it, and I get really mad because they'll put like the peak slightly off. But 85 should be somewhere in there. I have seen really weird ones where 85 is not in there. So really good question. And the thing is if you just guess through it, what you want to do is you want to know these key concepts about the conditions to know if it's normally distributed. You want to know the formulas and the notations and understand these key concepts because you can solve a lot of this chapter if you know this page of information and know how to use it. Let's do the data analytics. That was a really good question, Noel. Thank you so much. Really tough one. Can I do data analytics in like a few minutes? Okay. If you're watching this, I want to tell you how to ace the data analytics. I want to tell you why people will lose points. The big reason people are going to lose points is they don't look at how the graders are grading it. I want to say this. If you look at the rubric and you believe you did everything that rubric asked you to do, you need to email me or your instructor. Well, email your instructor. Don't email me if I'm not your instructor. Please don't do that. I have no say over your grades if I'm not your instructor. But if I am your instructor, please email me. And what I mean by this is the syllabus and the rubric are how we run the class. So what we're going to do is we're going to look at the rubric and make sure we understand the requirements. Okay. Information at the top. All you do for this one, you go up here, you copy this in, you put in your info, you make sure it's clear, you're good to go. You got a point. So we're good on that. Executive summary. The first thing right here is the reason why. Outlines what is being researched. This is part of the executive summary and should orient the reader to who the company is and what they are researching and why they are researching it. So you've got questions right there. So you can say, this is the company. Don't say this is the company, but make it clear. Who's the company? What are they researching? Why are they doing it? A strong sentence or two, maybe a very strong sentence. Look at it. The company is identified and the goal for the research is stated. So that is going to be your start right there. That is start of executive summary. The point of an executive summary is a one-pager. You hand the person a page and you're like, this is the report. They're like, well, what's the report? And you're like, if you want to read the full thing, you can. The executive summary is like the cliff notes. It's everything of importance. So you're trying to give them the full report as a one-pager. So it can be shorter. It can be like a half page, but it's an executive summary. It should have everything of importance. This is where people make the biggest mistakes. This is where the wheels fall off the car. The executive summary gives a summary of important details throughout the report. Note, not all findings are key findings. So you actually have to read the report. So what a lot of people are going to do, unfortunately, is not read the report. So let's go over here, go to the report. And please do not, we're going to, no. Okay. Don't include the instructions. Don't include, you have to go in here and read this report. You have to go in here and read this report. You have to look through here. It's not that long a report, just a few graphics. You have to think what was important right here. You have to look at the company. You got to look at the company right there. You got to talk about the company. You got to talk about what's important. Don't copy paste from this. Put in your own words. Don't copy paste from this. And you got to think what's important from this. High school GPA. What'd you learn from that? What'd you learn from distance students from campus? What'd you learn from honors program with student loans? What'd you learn from are you in an honors program? What's your GPA? You can see important things right there. And in summary, you don't just copy paste. Don't just go here and copy paste. Think about what you learned. Think about what's important. Think about what you care about. So you have to sit down for maybe 5-10 minutes and read this report. Just take a few notes. Be like, oh, this and this. Now here's where the problem occurs. Look right here. Numeric backing. Yeah, that's the company. Good questions, Caroline, right there. So that is the company. Yes, you want to talk about the company and who are they? Why are they doing this? Why does this matter? What's the point? That should be the opening to your executive summary. Make sure it's clear. Who are they? What are they doing? Why do they care about this? So the very opening right there is going to be what is being researched. The company is identified and the goal of the research is stated. That's the full marks right there. So it should orient the reader. Who is the company? What are they doing? Why? What's the point of the research? So very important right there. And then when you get to the key findings, this is where people make huge errors. If I'm grading these, the first thing I look for is numeric backing. What do we mean by numeric backing? Well, if I'm going to tell you a report right here on my model, if I say something like, I found a model that was statistically significant, that doesn't have numeric backing. So I found a model that was statistically significant. That's no numeric backing. So one second. I'm allergic to something in my office. I found a model that was statistically significant with a p-value of, and it's extremely small. I'll just copy it. There we go. Does that make sense what numeric backing is? People say, what's numeric backing? And I'm like, the numbers, the values. Like, you can see also if we say something like, all the information we need should be on the paper. Exactly. You don't need to be calculating things. Correct. Yeah, I see numbers throughout this report. All throughout this report. If you think about this report right here, let's go back to it. So you can see right here, new numbers. Boom, numbers right there. You go right here, numbers. You go down here, numbers. Does that make sense? Yes, great job, Caroline, right there. I think that's kind of important because that's, the data, the medians are the measure of central tendency. We talk about that in chapter 2 and chapter 3. There's numbers. You need to include numbers. That one's a descriptor, but it's still a number. So you need to include the numbers, the numeric backing. And I get mad when my graders take off points for adding too much. Does it still have that in the syllabus or the rubric? Not the syllabus. I keep saying syllabus. Where did the thing go? Here it is, over here. Too much is really subjective. You just don't want to give the whole report. It's better to give more than little. And so you just don't want to be like copy paste. Exactly. You don't want to be copy pasting. And I'm going to communicate with my graders, be nice if they give a lot. I prefer people who give more than less. But you don't want to rewrite the whole report because then why is it a summary? If you just give them the full report again, you're not summarizing it. So you have to be like, how do I condense this down? Next, we have an action item. What's an action item? Well, if I'm looking over here at this model right here, I need to be very direct. Action items are direct and related to what we found. So I'm looking down here at miles per gallon, I don't want to predict miles per gallon. I want to predict miles per gallon, excuse me. So I want to predict the miles per gallon of a car based on the weight, the cylinder, and these things right here. Let me look at the summary of this. And we want some cars that get good mileage. Wait, did I not? Oh, I called it a different thing. Okay. So what do we see? The most influential thing when it comes to miles per gallon is the weight of a car. So does that make sense? You're summarizing the report, exactly, turning it into an executive summary. So you're creating a summary of it. So we only have two. So, well, this is the third. So you have in your executive summary. Well, so the executive summary has three parts to it. The first thing is, who is this for? What's going on? What's the point of this? Next, a summary of the report. Finally, what are we going to do? This is all the executive summary right now. So with my action item, which I'm talking about the action item right here, I would say, since our goal is to make cars that have miles per gallon that are great, we noticed that the weight was very influential in miles per gallon, and we are going to be trying to make lightweight cars to achieve the higher miles per gallon that also have lower cylinders. So we're going to make 4-cylinder cars that are lightweight to sell to our consumers who want the high miles per gallon car. Now, that might be obvious, but as the company, this is what we've decided to do based on the data that we see that the association between weight and cylinders are the most significant in the model. I would quote those p-values. Does that make sense? What I'm telling the company, we're going to make lightweight, low-gear cars. Does that make sense what an action item is? I'm saying what we're going to do. That's an action item. You be direct. As a company, we are going to be making low gear, lightweight cars to sell to the consumers who want cars that get good miles per gallon. You're like, well, yeah, that's what, if the car's lightweight and has low gears, it gets good miles per gallon, like a little Honda Accord. Nothing wrong with that. I like my Honda Accord. I have a Nissan Altima now. I like that car too. Brian gets every dad car. Gotta catch them all. So does that make sense what the action item is right there? The action item is not for future. This is like directly related to the report. It is kind of future, I do get that, but it's directly related to what was found in the report. So you look through and you're like, the action item is listed in the executive summary and has some logical reasoning based on what we just found. So you think, what did this report do? Like, what did we investigate? So what are we going to do? It's not what we're going to research. So don't think of it as research because that's future research. Think about like, what are we going to do? So when you get to future research, this is just make sure 5 to 8 sentences, clear formats. So try to keep to that 5 to 8, and then they can't complain if you wrote more. I mean, wrote between that, they can't say you did too much. But I'd go more towards 8. But if they tell you too much, talk to me or your instructor. Future research is new ideas. So you know what we didn't investigate in this cars data set? We didn't investigate electric cars. My future research would say something like, with the advent of electric cars, this is something our company needs to highly consider. None of the data here considered new cars. And please don't use my wording. I read in reports now. Do not copy what Brian says. I'll read in reports. With the advent of this, our company needs to investigate this. We did not consider this. So don't use my words. This is just ideas like, what did we not look at? What have we not thought about? Well, my data right here, you can see it on the screen, the variables, miles per gallon, cylinders, displacement, horsepower, drat. Don't even know what that is. Maybe I'll teach my people what drat is. Weight, Cusack, VS, that's V versus straight line for the pistons, AM, automatic, gear, and carbs. Got carbs in this model. So with the future research, it's new ideas related to what to investigate. It's not about what the company's going to do per se. It's what they're going to think about in the future, which could be lead to action items or lead to research, hence future research. So future research is about like, where did we not do this research properly? Does that make sense what future research is? It's looking at the research you've done here and think about, well, I really would like it if we had some electric cars in this data set to take a look. I really would like to see electric cars in this data set to see what is lacking in the research methodology. Does that make sense? Future research is clear as where to proceed and also connected to the report, as in what is lacking in the research you did and you probably need to do more research on. Like, we need to really be thinking about looking into this and examining this, and our company needs to be aware of this. Like, we're always trying to be future-proofing ourselves. It's not necessarily what we're going to do, but what we need to be aware of and what we need to be considering and maybe collecting data on. So future research is what we need to be aware of, be thinking of, and what we need to be collecting data on. And it needs to be connected to the report to some degree. I researched cars. I didn't include electric cars. I should put them in there. And once again, this one's pretty clear. So here's what I would do. My last suggestion is what is called the AI sandwich. So once again, I want to promote UTverse. Maybe people don't know UTverse here. UTverse, really great. UTverse, UTK, I'm going to pull it up right here. Shout outs to Dan and Mark and everyone over there at OIT. And I think he's at OIT. I mean, they are just doing crazy things. To think our university has its own AI, pretty darn cool. And I'm pulling it up here in the background. With that said, what is an AI sandwich? People maybe know of this, maybe they don't. So what you do is you write out your own ideas. So you say, here is my executive summary. So notice I am giving it, now one thing I want to tell you, even with internal UT AI, I wouldn't upload personal things. So I wouldn't upload names and socials. Do not do that. But I never upload personal things. And I don't know if it's going to love this right here. I don't know if it's going to love this, but let's find out what it says. I'm kind of being quick on giving things to the AI because if it can do this, okay. Let's see what it says. Wow. Boom. Look at this. I would have graded this. If someone turned that in, I'd give it a 1. I'd give it like a 1. What do you think I'd get as a grade with what I wrote? I'd give it a 1. 1.25. Look at that. That's insane. I said 1. And there's grading variation. I'd give it a 1.1. I'd give it a 1. And they gave it on vague statement without numeric backing. Look at this. It's the graders would do. That's crazy. It's telling you don't have numeric backing right there. The company is identified, but no clear reason for research given. I know. And all I did was copy paste in the rubric. Took all of 10 seconds. So what do? You go back to the drawing board. You go back to the drawing board, you rewrite it, you try to improve it. And I've got something a student sent me. I wonder if I can, he said I could use his work for now and in the future. Let me go grab his assignment. So huge shout out to the student right here. I might call him student in the report. We'll kind of end with this. I want to show you, I'm forever impressed with what they did. He said I could use it because I said, hey, can I use this? And he said, yeah, I'd be honored. So I'm going to download his work right here. I can show it on screen. I can show him there now. I'm going to go speed grader. I'm going to take what he wrote, which has different requirements. This has very different requirements for what he did right here. So what he has right here has very different requirements. You'll see it in a half second. I have another student who did great work too. So once again, permission was given to share this with students, just making that clear. This was an NFL assignment students did. And you see right here, even started with a kind of opening on what's going on. He didn't, you would think, I think we know who the report is for. I think he's identified who this is for. It's for the NFL. You got some really nice scatter plots right there. Beautiful. You've got good tables. You've got, you remember normal probability plots right there. You've got checking for multiple models. Then you've got another table of output. Then you've got down here the best graphic I've probably seen in a long time right here showing the top 10 quarterbacks. So amazing work right here. So really good report. Let's see right here. This is a different thing where you're giving this is more of an introduction. Let's see. I gave this report like, just saying, I'm showing you it for a reason. I'm not going to say grades here, but you've seen it for a reason. Just, put the dots together. But according to the rubric right here, let's see what it says. Grade this according to the rubric. It's probably going to say the company's not identified enough. It's probably going to say the action item is not identified enough. It's probably going to give it like a 7 or an 8. Oh, he didn't include the information, so that's going to knock it a point right there. So you can see where it's losing points. It's got a 4. So it's telling you what to do. Add your personal information. That's the point. Include an action item. I said like there was no actionable. Propose future research. Oh, because he didn't have future research on there. So he got, but if you look at the things that matter, key findings. Key findings was there. Reason why, partial credit. Yeah, the report aims to understand the impact of quarterbacks on Super Bowl winning teams. However, a company is not, like I said, NFL was identified. So you can kind of think about this and how it's done. I know who gave the report. I know it's for NFL. Key findings is there. Action item. We're not doing that so much in 320 because we're just focusing on writing reports and kind of the understanding of it. I could have them include action items. I have done that. You're welcome, Caroline. Yeah, and so do the AI sandwich thing where you create something, you give it to the AI, and then you improve it, or you could even ask the AI, like, you give it the report. Once again, don't upload personal things here, but man, you can do so much with AI. And then it can just tell you, like, it's insane what it can do. It's like, it's just grading it for you. And if the AI says you should get like a 4 out of 10, you're like, what did I do wrong? I didn't write a future research thing. And I have no format for my future research. So, yeah, good stuff. Until then, bye for now, everyone. Bye.